Okay, so the next question that we have here is we want to find the equation of the line parallel to the y-axis. So we want to find the equation of a line which is basically parallel to the y-axis and drawn through the point of intersection and drawn through the point of intersection through the point of intersection of the lines x minus 7y plus 5 is equal to 0 and 3x plus y is equal to 0. So when the line is parallel to the y-axis, basically that means that the slope of the line is actually undefined. Now we will talk about that more, but then the line also passes through the point of intersection of these two lines, meaning that if you take these two lines and basically call this equation number 1 and call this equation number 2, then if you multiply 1 by 3, you will get 3x minus 21y plus 15 is equal to 0. And I write 2 as it is, so that is 3x plus y is equal to 0. So, and basically now if I add these equations together, what I will get is basically these two will cancel out. Negative 21 minus 1 is equal to negative 22y plus 15 is equal to 0. Negative 21 plus negative 21, basically negative 22y plus 15 is equal to 0. Negative 22y is equal to negative 15, and y is equal to 15 by 22. Now if y is equal to 15 by 22, then over here, for example, we said that 3x plus y is equal to 0. That means that 3x plus 15 by 22 is equal to 0. 3x is equal to negative 15 by 22, and so that means that x is equal to negative 15 by 22 divided by 3, which is negative 15 by 66. So that is your point of intersection. That is the point of intersection of these two lines, which is basically negative 15 by 66 and 15 by 22. Now, since we have the point of intersection, now we know that the line is parallel to the y-axis. Since the y is parallel to the y-axis, it has the same slope. It has the same slope as the y-axis. And the slope of the y-axis is basically undefined. What that means is that basically if you have some line, for example ax plus by plus c is equal to 0, then you know that the slope of this line is negative a by b, and this has to be undefined. This has to be undefined so that the line is basically parallel to the y-axis. Now, for this to be undefined, basically this will be undefined if b is equal to 0, meaning that if you're dividing by 0. So that means that b has to be 0. Now if b is 0, this equation becomes basically ax plus c is equal to 0, which means that basically ax is equal to negative c, or x is equal to negative c by a. Now that means that basically your line is basically going through some point on the x-axis, meaning that, for example, you have some line over here. So for example, if your line goes through the x-axis through the point 1, for example, this will be your line. And then you would say that, for example, x is equal to 1, for example, is the equation of this line. So now, since we know that the line goes through this point, the line goes through this point negative 15 by 66, which is some negative number over here, very very close to negative 1, and also 15 by 22. So that means that basically the x coordinate of this point is negative 15 by 66, and the y coordinate is basically somewhere over here, 15 by 22 over here, some number less than 1. So basically this point would be some point over here, and the line goes through this point. Now this is not important here because this is the y coordinate of this point, but you need the x coordinate of this point, and then the equation of the line becomes x is equal to negative 15 by 66. I think that is the equation of the line. So then number 6 is, of course you can simplify this, I suppose. Divide by 3, you will get 15 by 66. You divide by 3, you will get 5. Divide by 3, you will get 22. And that's negative 5 by 22, which is the right answer over here. Okay. Okay, so the next question is question number 7, which is find the equation of the line drawn perpendicular to this line perpendicular to x divided by 4 plus y divided by 6 is equal to 1 through the point where it meets the y-axis, and through the point where it meets the y-axis. So that means that the line has the same slope as this line. I'm sorry, it's perpendicular to this line and through the point where this line meets the y-axis. So we need to find the y-intercept of this line, and you know that this number over here 6 is the y-intercept of this line. So your y-intercept is basically this line over here, x divided by 4 plus y divided by 6 is equal to 1. Over here your y-intercept is equal to positive 6. That means that this point becomes 0, 6. Now if this point is 0,6, that means that this point is one point on that line which we want to basically find the equation of. And also the line is perpendicular to this line. So if I write this line as, for example, 24x divided by 4 plus 24y divided by 6 is equal to 24, and that is 6x plus 4y is equal to 24, and then 4y is equal to negative 6x plus 24. 4y is equal to negative 6x plus 24, and y is equal to negative 6/4 x plus 24 by 4. And so y is equal to negative 3/2 x plus 24 divided by 4 is equal to 6. That means that the slope over here, the slope is equal to negative 3/2, this number over here. Now if I call this, for example, m1, and if I call the slope of the other line m2, since the two lines are perpendicular, we know that m1 times m2 is equal to negative 1. That means that negative 3/2 times m2 is equal to negative 1. Cancel these two out. m2 is equal to 1 over 3/2, which is equal to 2/3. So the slope of the line is 2/3, and this is 1 point on the line, 0.6. So you can simply write an equation for the line. Y minus y1 is equal to m times x minus x1. So y minus 6 is equal to 2/3 times x minus 0, which is basically x. So y is equal to negative 6, y negative 6 is equal to 2/3 x, or you can say that y is equal to 2/3 x plus 6. That is the equation of the line. So question number 7 is, or you can rewrite this equation. They have rewritten it in another way. They have written it as basically multiplied by 3, you will get 3y is equal to 2x plus 18, and then you can write it as negative 2x plus 3y minus 18 is equal to 0, and then you can write it as 2x minus 3y plus 18 is equal to 0, and that's the answer that they have gotten in the book. Any answer, of course, is correct. Now the next question that we have is, question number 8. Question number 8 is, find the area of the triangle formed by these lines. Okay. So you have these lines over here, y minus x is equal to 0, and x plus y is equal to 0, and x minus k is equal to 0. And basically I call this equation number 1, number 2, and number 3. Now, if these lines form a triangle, and as you can see, it's very interesting that for example here, these are two basically lines that, well, don't move. That's y minus x is equal to 0. That's x plus y is equal to 0. They are two lines that you can just draw them on an xy plane. But this line can move, meaning that you can change the value of k, and it's a vertical line. So then relative to this line, of course, the area of the triangle is going to change. So you can use this concept in many different ways, meaning that, for example, suppose that in some application you need, for example, some area which is enclosed within these two lines, and then, for example, the third line is moving. Then you can introduce some k or some constant in any one of those lines, and then you can just keep playing with those constants, and of course you can have as many constants as you want, and then based on those constants the area can change, and of course you can then actually put this into, I mean, use your algorithm and your information in some, for example, in some programming language, give it to a computer, and you can just enter a couple of numbers and it gives you, for example, the area of that triangle enclosed within the lines. Or you can even make a function out of that, and then the output of the function could go into other parts of your program. For example, suppose that in a program, for whatever reason, the area of this triangle, as it changes, the output of that function is required in other places to be used by other basically entities in your program. So you can do all of that sort of thing. Okay, so but now back to this problem. So the lines that I have over here, I have to find basically, most of the time it's easier to have a visual understanding of the problem. Now over here I have y is equal to x, number 1. So y is equal to x is basically this line over here. It's a line with a slope 1. This is y, this is number 1. Number 2 is y is equal to negative x, which is basically this line over here with a slope negative 1. This is number 2. And then the line number 3 can change, of course, meaning that k can be 0. K can be 0. If k is 0, then it will be the y-axis, and then you will have no area. If k is positive, it just keeps going along the positive side of the x-axis, and you will have some area over here between these two lines. And if it goes in the other direction, you will have the exact same area, because these lines are basically symmetric about the x-axis and symmetric about the y-axis. So you will have, basically, it doesn't really matter whether it wouldn't really matter whether your k was negative or positive. For example, -2 as a value for k, and +2 as a value for k would give you the exact same area enclosed within the 3 lines. So now suppose that for example I take some arbitrary hypothetical value for k, and I put my line over here somewhere. Let's say that this is x is equal to k, and so I have basically this vertex, and this vertex over here. And as you can see, the point of intersection of these two lines is the origin, so I don't have to worry about that. So the point of intersection of these two is the origin. The point of intersection of this line with this line and this line with this line, we need to find out what that is. Okay, so now in order to find the point of intersection of, first we need to find the point of intersection of the line, of this line, basically if I call this line number 3 over here, and so the point of intersection of 3 and 1, the point of intersection of 3 and 1 would be, so basically you have y minus x is equal to 0 and x minus k is equal to 0. So over here I get x is equal to k, and so if I put x is equal to k in this equation, I will get basically y minus k is equal to 0. That means that y is equal to k. So y is equal to k and x is equal to k. So y minus k is equal to 0. That means that the point of intersection of these two lines seems to be k comma k. Which does make sense because the slope of this line is actually 1, meaning that this line over here, y minus x is equal to 0, this line that you can write as y is equal to x. That means that any input that you give to this line, it's going to give you the same output. So if you give it any k, it's going to give you the same k. So that means that the point of intersection of these two lines therefore will be k comma k. K comma k. So this is the point of intersection of basically 1 and 3. The point of intersection of basically 2 and 3. Basically you could write x is equal to x plus y is equal to 0 and x minus k is equal to 0. So then from this you can conclude that x is equal to k, and so if I put x is equal to k in this equation, I will get x plus k is equal to 0. That means that x is equal to negative k. I'm sorry, no, I made a mistake here. So put x is equal to k in this equation, you get k plus y is equal to 0. That means that y is equal to negative k. And that does make sense as well, because the slope of this line is basically negative 1. So any input that you give to this line, it will give you basically the algebraic opposite of the same input, meaning that the point of intersection of basically of 2 and 3 would be basically k comma negative k. So this is the point of intersection. The point of intersection of basically 2 and 3. Of 2 and 3. So now we have basically these 3 points, which are basically k comma negative k, we have k comma k, and we have 0 comma 0, because the point of intersection of these two lines was the origin, which is 0 comma 0. So now we said that the area of a triangle, having 3 vertices x1, y1, y1 and x2, y2, and x2, y2, and x3, y3. If you have a triangle that has these 3 points, these 3 vertices, the area is going to be equal to 1/2 the absolute value of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. So this is the area of that triangle, of any triangle having these vertices in general. So now that the vertices are these, then you can say that the area of the triangle, the area is equal to the 1/2 of the absolute value of, take this as 0.1, 2, and 3. And so you will get basically x1, which is equal to k times y2 minus y3, so basically k minus 0, which is basically k, plus x2 is again k times y3 minus y1, so it's basically this is 0, and minus y1 would be again k over here, and x3 is basically 0, so you don't have to write it over here. So then you have 1/2 of basically k squared plus k squared, which is equal to 1/2 of the absolute value of 2k squared, and that is equal to, well, you can just simply take the 2, you can take out, and of course k squared you can take out, both are positive values anyway, so that is 2/2 k squared, which is, and 2 and 2 you can cancel out, which is equal to k squared. So the area of the triangle is k squared square units. So let's take a look at the solution here. The solution is k squared square units. Now the next question that we have is find the value of p so that the 3 lines may intersect at one point. Okay,